Hello everyone, this is Sri Guru over here. Welcome back to my YouTube channel. In the previous video we have discussed about the speed, average speed, and how we can calculate the average speed. And in this video I am going to discuss first instantaneous speed. Instantaneous speed means the speed of the moving object at that time of instant. That is known as instantaneous speed, right? For example, let us consider you are moving through a vehicle Hubli to Dharwad. Particularly at a particular instant of time, your friend calls to you and asked you to what is your speed of the vehicle at that instant of time. Immediately you see the speedometer and you can say that your speed of the vehicle is 3 km per hour or 4 km per hour. That speedometer gives the speed of the vehicle at that instant of time. It is known as instantaneous speed. Okay, right? Then how we can write the instantaneous speed? Let us consider delta S be the displacement, sorry, a distance of the object, not the displacement, it's a distance of the moving object, right? And that distance is traveled in a time t. Change in a time, correct? Then average speed, how we write? This is distance divided by change in the time, correct? If we apply the limit to this equation, limit of delta S divided by delta T, if that change in the time is very small, that is delta T tends to 0, that means very small, then this gives ds by dt. ds by dt. This delta t is we take only for the large changes, right? If the delta t is very small, then which gives ds by dt. This is the instantaneous speed, correct? We will solve this problem for instantaneous speed. We'll consider the next problem. Okay, now let us consider, now we are going to solve one problem here. Consider a man walks 1 minute with a speed of 1 meter per second. 1 meter per second. Next, the man walks 1 meter with a speed of 3 meter per second. Then first, initially the man walks 1 meter with a speed of 1 meter per second. Next, then the man runs 1 meter with a speed of 3 meter per second. Then what is the average speed of that man? Average speed of that man, correct? For that we know the basic formula. First, time, total time. First we require total time, right? The total time taken by the man to walk with a speed this and the speed this, he takes first 1 minute and next 1 minute, right? That means 60 seconds plus 60 seconds, which is totally 120 seconds. So 1 minute and 1 minute. Let us take this as a T1 and this as a T2. When we do T1 plus T2, which gives 120 seconds, right? Right? What is the total distance traveled by the man? Total distance, but distance is not given, only the speed is given. If we do velocity into time, which gives the distance, correct? That means total distance, velocity into time 1, velocity 2 into time 2, which gives the total distance traveled by the man, correct? Then simplify this. V1 is how much? This is a V1 and this is a V2. V1 is 1 meter into this time is 60 seconds. 1 minute is 60 plus V2 is 3 and this is 60, which gives take 60 common, 4 into 60, correct? 4 into 60 meter, 4 into 60 meter. We will simplify this later. Okay, next, what we require? Average AV, average speed, total distance traveled by the mind to total time taken. This is equal to total distance is what? 4 into 60 divided by, this is 120. 120, 2 get cancelled. 2 meter per second is the final answer. This is the average speed of the man. Correct? Note on this or take the snapshot of this board. Okay? Okay. The next term is velocity. Speed is different, velocity is different. Velocity is defined as, it is the ratio of displacement of an object to the corresponding time is known as velocity. Correct? And velocity is a scalar. Sorry, it is a vector quantity. It is a vector quantity. If I say velocity is a vector quantity, means it must have magnitude as well as the direction. Correct? That means if the object is moving somewhere like this, correct? And we know the north, south, east, west, we know all these directions, right? If object is moving like this, right? It is moving in a north direction, it is moving in a south direction, like that we can say the direction of the moving object along with the velocity. The object is moving north side with a velocity of 20 meter per second in north. We can say like this, correct? Along with the direction we can say the velocity of the object. Remember, right? This is a vector quantity. The next, velocity is measured, SI unit of velocity is meter per second. Meter per second, correct? Velocity SI unit is meter per second, or CGS unit is centimeter per second. Centimeter per second. And its dimensional formula, dimensions, L T raised to minus 1. L T raised to minus 1. Correct? L T raised to minus 1. Length divided by time. Correct? These are the properties of velocity. As we have studied speed with the different concepts, similarly the velocity is also different types of velocities. The first one is a uniform velocity. Uniform velocity. When we can say that the object is moving with a uniform velocity? If, let us consider, a particle is moving along a straight line. Correct? If the object covers 1 meter, this is 0, this is 1 meter, and this is 2 meter, and this one is 3 meter, like that. Right? If the object covers 1 meter in 1 second, and the second 1 meter is also covered in a 1 second only, and the third distance 1 meter is covered in 1 second only, then object is moving with a uniform velocity. That means equal displacement in a equal interval of time. Now see here, what is the velocity in between these two intervals? The velocity is 1 meter divided by 1 second, that is 1 meter per second, its velocity v1. Correct? Now look at the second one. From here to here, it takes 1 second only. Right? It covers 1 meter in 1 second. That is v2 is 1 meter per second. Similarly, look at the third meter. That is 1 meter from 2 to 3. And its velocity is covered in 1 second. Therefore, v3 is 1 meter per second. v1 is equal to v2 is equal to v3. Therefore, we can say that uniform velocity. Correct? Note down this. Okay, listen. Here we are going to study about the position time graph. What this indicate? Position time graph, which gives the position of the object at any instant of time, or how the object is moving, whether it is moving with a uniform velocity or decreasing velocity or increasing velocity, that can be studied by using the position time graph. The position time graph is that graph which require only two coordinates to represent the motion of the object. Along the x-axis we are choosing the time, and along the y-axis we are choosing the position of the object. Okay, now look at the first one. The object is at rest. That means at any instant of time, as the time go on changing, the position of the object does not change. Such position time graph is like this. As I said, along the x-axis I am choosing the time. Correct? This is x-axis. right? This is the origin and this is the y coordinate. Along the y coordinate we are choosing the position. If I consider at a time t is equals to 0, the object is somewhere at here, right? After certain interval of time, that is after 1 second, the object is remains here only. After 2 seconds, the object is here. After 3 seconds, the object position does not change with respect to y. That means this line is parallel to the x-axis, right? This is position time graph, right? For the object is at a rest. Now look at the second one. The object is moving with a uniform velocity. Now see here. Once again, along the x-axis, I am choosing time only. This is the origin and this is the displacement. Sorry, this is the position. If I consider this is the origin, the object is at here, correct? After 1 second, it travels 1 meter. The object position is here at 1 second. After another 1 second, it covers 2 meter, right? After 3 seconds, the object is at here. Therefore, from the origin we get a straight line which intersect the y-axis. Sorry, it intersect the origin. This is a straight line which originates from the this is, right? Correct? If you take the slope of this object, slope, which gives the velocity of the object, right? Which gives the velocity. If this is the slope A, B, C, slope, right? Slope is nothing but here only AB divided by BC, which gives, that is change in the position to the change in the time, change in the position to the change in the time, which gives velocity of the object, right? This is the position time graph for object is moving with a uniform velocity, correct? Now look at the third one. Object is moving with a constant negative velocity. Constant negative velocity. Here the velocity is positive because the displacement is positive here, right? But for the negative velocity time, this is x-axis and along the y-axis the position. At the time t is equals to 0, the object position is somewhere here, right? After 1 second, the position is reaches here. After 2 seconds, the object reaches here. Therefore, it gives like this. If you take the slope of this object, then velocity is negative. Velocity is negative. This is just VEL, but velocity is negative. Correct? Object is moving with a variable speed. Variable speed. Variable speed means initially the object velocity is having 3 meter per second positive. After certain interval of time, the velocity becomes 0. After certain interval of time, the velocity becomes negative. Correct? Like this. Initially, along the y-axis time, the position, directly it is get increased. Uniform velocity is traveling with a uniform velocity. then it comes to 0, and next it get initial curve, and finally it may go like this. This is variable velocity. At a different instant of time, the velocity, the position of the object is go on changing. Correct? Is it right? This is variable velocity. Remember. Note down all these points. Thank you for watching my video. We will discuss some more graphs in the next video. Okay, thank you.